this is Michael from Expanse VR. In this new how-to series, I will be looking at a new programming or Unity concept in each one of these videos. In the future videos in my other series, I will reference these individual how-to videos as well, so you can expand on your knowledge and should make those other videos easier to comprehend. In this video, I will be looking at events and showing you why they are fundamental to any one of your projects and how to easily incorporate them. And if you're new to the channel, don't forget to like this video, subscribe to the channel, and of course click that notification button down below to make sure you are notified whenever I post a new tutorial for you. So what exactly are events? If you think about a transmission tower, which the technical term is the subject, it broadcasts out a signal not knowing or caring who is listening. Then you have multiple listeners, again the technical term is observers, listening out for a particular signal. Again, they don't care who is sending out this signal, and there can be one or many observers listening out for that particular signal. This is how events work. You have one class broadcasting out the event and one or more classes listening out for this event to be called. And this is a fundamental concept in object-oriented programming known as the observer pattern. There are many benefits to using the observer pattern. The first being decreased dependency. As you've seen from the example, objects don't need to know about each other. Accessibility. You don't need to make major changes to your code to take advantage of the events. Flexibility. Again, as you've seen from the previous example, listeners can come and go with ease. And finally, cleaner code. And as you'll see in the upcoming example, it just makes for cleaner and more efficient coding when you use events. So jumping straight into Unity, we've got a very simple scene here, just a simple side-scrolling shooter. And just to give you a bit of background about the scene, so our player has a player controller script on him, which is just handling the shooting. The enemy has a enemy script on it. Our canvas has a UI manager, and the bullets that we instantiate have a bullet controller script applied to them as well. So just 4 scripts that are controlling this scene at the moment. Now, if we push play, we're going to see one first issue that when he pushes play, the cart gets in the way. And if I disable the cart, he can shoot and destroy the enemy. Now, there's a couple of things that we want to happen in this scene that are not quite happening at the moment, and we're going to see a couple of different ways of going about it. The first thing we want to see is, instead of the enemy just disappearing like it does at the moment, we want it to go through a death animation. The other part is we do want to be able to destroy that cart so that we can get to our enemy, and finally we want to be able to update that score. Plus, considering that we're killing the enemy, we want to give the player some XP when that happens. So let's start with the bullet controller script first. This is a very simple class. It has just a rigid body, which when we start, it just adds some force to make it fire. It then has a collision enter function to detect whenever it collides with anything in the scene. And at the moment, all we're doing is looking to see if the tag of the object that we hit is the enemy. And if it is, it destroys that object, and then it destroys itself. I've commented out this section here because this is going to be one of the ways that we go about detecting other objects. Because of course we don't want it just destroying everything in the scene. So what we can do is add a tag to the cart, which is blocking things. And in here we've got a block, and it will do the same thing and destroy it. So if we bring these lines of codes back in, so now it's doing 2 things. It's detecting whether it's hitting an enemy, it's detecting if it's hitting a block. Jumping back into Unity, we push play, and now it's destroying our 2 things. Now, while this might seem simple, we've only just got 2 if statements, you're starting to see what problems could arise as we start adding more and more objects into the scene that we want to destroy. Now, we could simply add a different tag that says destroyable, or something along that lines. But as you can see, it's starting to get a little bit messy, and this could get longer and longer. Also, you want to limit the amount of tags that you do use. Tags are good to use in some circumstances, but you do want to limit them. But again, we are seeing an issue where this is not working as well as we would like it to. But we're going to continue on. Now, at the moment, we're destroying our enemy, but if we have a look in the enemy class, we actually have a damage function that we could use to damage it, because this guy's actually got 3 health points. So it'd actually be better if we could actually just, every time we hit it, it took off 1 health point, and when it reaches 0, it destroys itself. So what we could do, and what I quite commonly see in other examples of people putting their code up, is that if we detect the enemy, so we know we've got that one, instead of destroying the collision, we could call its damage method. Collision dot transform get component enemy dot damage, and tell it how much we want to damage. In this case, we'll do 1. We could make a variable for this, but let's not worry about that for the moment. So if we imply this now, this should work. All right, and just pushing play. 1, 1, 2, 3, and our enemy is dead. So this is obviously working. We've now damaged our enemy, and our enemy is doing this, but again, we've got this issue here where we're using a get component call. And depending on how many times we're shooting and how many other enemies, we could be doing several of these get component calls every second. And the only time you want to be using get component calls is in your start or on enable methods to cache. And if you're unsure what caching is, we'll do that shortly. But we're going to leave this here for the moment. But again, I see this so often with other people's codes and in other tutorials. You want to avoid this whenever you can, and you should be able to avoid this most of the time. So going back to our enemy, we've still got 2 other things that we need to do. The first is update the scoreboard with our score. And if we look in our UI manager, it's a very simple one here, which is update score. So we can do this in a couple of different ways. One way I've seen people do this, which is very, very much the wrong way, is they will do find object of type, UI manager, update score, and in this case we'll say you get 20 points for killing this guy. Now this will work, but it's definitely not the right way to do it. It might be okay for doing something like prototyping, like here where we're showing it, but this is very bad practice. And again, you might do the same thing here, find object of type, player controller, and I forget what we call this, add experience. And we can say he gets 50 experience for doing this. We'll quickly actually switch this to public so we can see the increase. So it quickly changes to public so that we can see the increase in experience points. So now, when we shoot, 2, 3, he's dead, our score's done, and our experience points are updated. So again, we have these find object of types, and we have our get component call here in our bullet manager. But why are these bad? The simple answer to this is that they create garbage whenever you use these ones. I'm not going to go into too much about that. It's more to do with profiling, and just need to know that you do not want garbage collection when you are creating your games. And doing find object types and get component calls create garbage. The exception when you can do this is at the beginning of the game. And so for instance, one better way of doing this would be instead to to do UI Manager, and what I'm doing here is actually caching these variables so that they can be accessed later on. So now we can do our find objects. So if we take this one away, equals, and same with our player controller. Now, a better practice would actually be to check to make sure that null check to make sure that there actually is a UI manager and a player controller, but we're not going to worry about that for this one here. But what we can do now is change this to UI manager, and player controller. So now we've got a much better system for it. And this isn't bad. And if it was a small scale project, this would be perfectly acceptable. But again, what happens if we want to do more than this with the def function? And later on, if we want to add on, it means adding in more and more code. There is a much better way. And so what we're going to do now is we're going to fix up this section here for our def function. And in our bullet one, we're going to also change these up. So we're not doing all these if-else statements. So now we're going to start using events. And the first thing you need to know when using events is that we're going to make sure that we have the using system at the top here. Events always go at the top of your class. And it's simply public static event action. And then what you want to call the action. So in this case, we're going to call it on death. Actually, we don't need those for the moment. So public static event action on death will create your event, which precedes events. But this is all you need to know at the moment to create your first event. Just use this syntax here. Now, this is setting up the event. Now, to call the event, we are going to do this. So the first thing we need to do is check to see that anyone's actually listening. Before I said that the subject doesn't care if anyone is actually listening, but that's not entirely true because we don't actually want to call something if no one is listening. And all we need to do is check if on death is not equal to null. We then call on death. And so what this is going to do here is it's going to broadcast out to anyone that is subscribing to this on death function. So for the moment, we're going to get rid of all this because we're not going to need it. And actually, one thing we're going to see there is that we do need to pass in some information. And the great thing about this is that you can actually pass through information when you do call an action, when you do call an event. So what you need to do in here is do int. And as you can see, it's now giving us an error saying that we need to pass in a variable. So we're going to pass in the amount 50. So if we now go to our player controller, Our player now needs to actually subscribe to this. And all we do this is on enable. And we go simply bullet controller dot, no, sorry, enemy dot on death plus equals, and what function are we using for that? Add experience. And it's as simple as that. And we just need to also, as best practice, also unsubscribe when we disable the object. This just makes sure that it's still not listening out for anything once it actually has been switched off or destroyed. So let's just test this first one out. So this one is just when we die that our player gets experience points. So we've got a player, we push play. 1, 2, 3. And as we can see, our player has his experience points. Now for our UI manager, same thing. Enemy on death and this time if we watch our score, 1, 2, 3, our score's gone up and our experiences points has gone up. So if we go back to our enemy, besides being able to clean up those lines of code here, we also can now remove this and this. So now we've reduced all that down to just this little bit of code doing the exact same thing. And now if we go over to our bullet one, we're going to see the same thing. Because the truth of the matter is, the bullet doesn't need to know what it's hitting. It just needs to know it's hit something and then broadcast it out. So we'll do the same thing here. Public static event action. And this we're going to pass, oh, I forgot to use .system. I'm going to pass in a game object, and we're going to call this on hit or on collision. Now I've shown you the longer way of checking for this, but we can actually do this in one line of code. We can actually just call the event, and by just putting the question mark there, this will actually check for us. Same thing as doing a null check. And then we go dot invoke. And invoke's only going to be called if the on collision event actually has a subscriber. And again, it's giving me an error because I haven't put in a variable. So it's collision dot game object. And we're actually going to get rid of all this now. I'll quote it out for the moment. So the first one we're going to go to is our enemy. And this is the great thing. You can have events being called by a class, and you can also be listening at the same time. So on enable, So bullet controller dot on collision equals damage. Again, this is going to give us an error because our damage here is looking for two things. It's looking for an int, so we're actually going to add this in, and this is where I'm going to show you how you can actually have two variables being passed. One for the damage. So we come back here. We now need to add a game object. So what we're going to do here, oops, that should be capital G. We're going to check to see if the collider object is this object, which is very simple. If collided does not equal this dot game object, we return. So we could do other things, put in brackets, but basically this make it nice and simple. If the collided object is not this game object, we return outside of this function. Else we continue on as normal. So this is not going to work for the cart just yet. So we'll get rid of you. But it will work for our enemy. 2, 3. Done. So what we need to do now for our cart is create a new script. Get rid of all this, on enable. Now, even though we really don't need some of this information, we do need to still pass it in. And I just usually ignore this when I don't need that particular piece of information that's being passed around by the event. And same as before, if collided equals, actually this one is this dot game object. We'll do this the other way around. Destroy this dot game object. And then all we need to do is hit. And here I'm going to give you an example of why we need to do the on disable and to unsubscribe to the event. So if I push play now and I destroy the cart, works fine. But all of a sudden our enemy isn't interacting the way it was before. No errors. So what's happening? Simply put, to fix this, and there we go. And if we hop back into our bullet controller, we can now clean this up again, and we have much cleaner code. And the best part is, if we look at, say, our enemy here, if we wanted to have anyone else react to this enemy dying, say there's a special door that needs to open up, or a certain amount of enemies that need to be killed for a certain function to hit off, we don't need to touch our enemy script at all. All we need to do is have someone else subscribe to it, and away we go. This makes things a lot easier, a lot cleaner, and also makes your games more efficient when running. So this is the end of the first of the how-to series of videos that I'll be doing. I hope that this has been helpful and beneficial, and that you like this sort of format. If there's any other concepts or Unity functions that you would like me to do similar videos on, just comment below with what they are, and I'll see if I can help you out with that. If there's any questions regarding this video or any other ones, definitely have a look to it. If you look above now, you'll see a link to the first-person shooter series. The third episode will be using this event function quite a bit in a slightly different way, but you'll see it being implemented in a functional way in a game. So thank you once again for joining in, and have a Merry Christmas. And thanks for watching. Don't forget to like and share to help grow our beautiful Unity community. And don't forget to hit that subscribe and notification button below to make sure you get to see our next video. See you shortly.